So today I want to share with you a story. This is a story of how a few colleagues of mine and I achieved something that I think is actually pretty cool. It's a story of when you combine 3D printing, this rapidly rising technology that everyone's talking about. Even President Obama gave it a shout out in the State of the Union address. This is what happens when you combine that with traditional medical technologies. And we think what you get when you do that is pretty cool, and I think you guys will too. So the story begins when I joined the lab, Dr. Matthew Levy in the integrated imaging facility here at Notre Dame. Pretty much the name of the game in the imaging facility is pretty straightforward. We take pretty pictures of things, is what I like to say. And so the name of the game is usually, find the tumor, track the cancer, investigate the bone structure, that sort of thing. And so we do in vivo imaging, which is live imaging, which means there's no harm to the subjects that we image. So they go into the scanner, we scan them, and they come out good as new, just wake up as if the procedure never happened. And so one of the most popular imaging methods that we do is called X-ray CT, which is essentially a three-dimensional X-ray. So if you break your arm or your leg or something, you go to the doctor and they take one projection of your arm. It's a two-dimensional, it's a planar X-ray scan. But a CT takes hundreds of projections in a circular room, like you can see up here. And you end up with, after computer reconstruction, with a three-dimensional X-ray. And CT is really useful. You can scan many, many different kinds of things. You have innate projections, which you can do like adipose tissue, lungs, the brain, or you can use X-ray CT contrast agents when you can get the kidneys, the liver, that kind of thing. So X-ray CT is very useful for just a wide variety of investigations for preclinical and clinical trials. But the problem with X-ray CT is you're still stuck with slices. So when a radiologist investigates a broken bone, or we're investigating mice, you're still stuck with these slices. And even though you can construct it out to be these beautiful 3D images, it's still stuck in a 2D screen. And so when I first joined the lab, I kind of struggled with that, I couldn't visualize it very well. The 3D images, stuck on that 2D screen, I can't see around it, move around, and it's just, something that we wish we could change, wish we could improve. And so I learned about 3D printing. And everyone's been talking about it. It's supposed to, revolutionize manufacturing. Wired called it the machine that's going to change the world. It's called the next trillion-dollar industry. Well, the last trillion-dollar industry was the computer. So you can kind of get a feel for what they think the 3D printer is going to do to the world. I think it's going to change it. But what exactly is 3D printing? So 3D printing is a new way to manufacture objects, where instead of you use a mold injection or some kind of drill machine, you print the object layer by layer by layer. And you can see up here, when you create the object, it affords you the ability to make unlimited complexity. So any object you can imagine, you can make. There's no limitations on drill bits and where you can fit the drill, or getting a mold out of the object. You can make anything you want, and that's really powerful. Secondly, you have an unlimited digital inventory. So I can have a USB drive with 10,000 objects on it, as many as I want, and I just plug that into my 3D printer, and within a matter of hours, I have that object, instead of having to go to a warehouse where I have all my objects stored. And along with that, rapid production. I can walk into the lab in the morning with an idea in my head or something that I want to print out, and walk out with that object later in the afternoon, having that object in my hand. And so when you combine all those three things, you get a really powerful technology. You get unlimited complexity, you have unlimited inventory, and you have unlimited speed. And so when you combine all those three things, you just get a ridiculously powerful manufacturing capability. And so here's some examples of 3D printers. It used to be that you could only get a 3D printer if you worked at a high-end design company. You could get one of these ProJet 1500s that cost millions of dollars. But as the technology has progressed, it's become cheaper for the high-end and for the low-end. And so anyone could get into the 3D printing game. The MakerBot Replicator, the first 3D printer we had in the Levy lab, at a price point of $1,500, pretty much anyone who's motivated could get into the 3D printing game. And so we're seeing these fabrication laboratories, Fab Labs, spring up all across the world. Giant buildings full of 3D printers and 3D printing specialists who you can walk into their room and say, I want this, or I want a copy of this object. and then you can walk out with it, hours later. And that's really powerful. I think it's really changing the way that we're thinking about objects, and it will continue to change it as 3D printers become more relevant and prevalent in our lives. So instead of seeing your buddy's iPhone case and, hey, that's a pretty cool case, I think I'll go order that off Amazon, get it in a few days, you'll think, oh man, that's a cool iPhone case. I think I'll download the file for that and print it out later tonight on my 3D printer. And so you have these powerful technology, this unbelievable ability to manufacture objects, and we wanted to marry that with medical imaging. And so you might see where I'm going with this. We have these beautiful 3D images that are trapped on a 2D screen, and no real way to bring them to life in the real world with traditional manufacturing. So what we did is we decided to develop a method to take those images off the screen and put them in the palm of your hand. And so this is one of the first 3D prints that we ever made. This was just a rat that was crawling around in our laboratory that day, and we scanned it and printed it out hours later. And naturally, since this is Notre Dame, we coated it in gold. But this is just a really powerful communication tool. I can look at that object, spin it around, look at what I want to, and see further areas that I want to investigate. So we think that's a really cool tool for communicating. And here are just some options that we investigated to be able to 3D print. So you have like third-party companies, different quality printers, which go along different timelines and price points and such. And we published all of that in a published process in the Journal of Visualized Experimentation. Now this is an open access journal, so anyone could go look it up. If you have a beloved pet and access to a CT scanner and a 3D printer, you could print out a copy of your beloved Fido. And we were really happy with that. We were excited that we developed this method and were able to publish a paper on it. And it turns out a lot of other people were excited about it too. Wired contacted us, Wired Magazine, and wanted to do a short piece on our work. And it turns out after that, NBC News got excited about it. And The Scientist, and Medical Daily, and Engadget, and 25 other independent news sources ran articles about our research. And so we were really excited. We had exposure, we had a great project, but we didn't really have an application. So right now we had a cool project, but we didn't have a useful project. And so we started searching for that golden application, something that we could use this to be useful in the real world, not just be a cool visualization tool. So we started with education, the first avenue we pursued. You have an anatomy classroom, the size of this lecture, the size of this room, and you have one professor with one prop. Skulls and skeletons are pretty hard to come by. A skeleton's going to run you for like $5,000. A skull will cost you about $1,000. And so it's really difficult to get real life-size props for anatomy classrooms. But we decided that if we used our method to scan those props and then print them out, everyone in the classroom could have their very own 3D printed skull to take with them, study, do whatever they want with it in order, to learn that material. And so we thought that was a really powerful tool to be able to, improve education like that. But that wasn't the golden application we were searching for. It was good, but it wasn't the one. And so we came back to, PET CT scanners, and we tried to improve PET CT scanning with that. And in short, the way you calibrate a PET CT scanner is with what we call a phantom. It's supposed to be a representation of the object that you're going to scan. And the current method for that is, these cylinders full of solution. And obviously, I can see quite a difference between the cylinder full of solution and the actual mouse or rat that we wanted to scan. And so we decided that if we wanted to calibrate these machines properly, we had to print out better phantoms. And we're currently in the process of engineering and validating these phantoms to make them so that we can improve the accuracy and reliability of CT and PET scanners. But that still wasn't the golden application. And it wasn't until one of our lab members fell ill and had to go see a sinus surgeon that we realized what a real application for this could be. Everyone in this room has different physiology. It's slightly different. We all have the general features that are the same. But your sinuses and your sinuses are different. Nose and throat areas are going to be different on every single person. And that can be a real problem for surgeons that want to go in and modify that physiology if it's different from person to person. And so our application was, they have CT scans they use as a guide, but it's kind of crude when you're looking at just the slices on a computer screen. And so our application was to take those CT scans that surgeons normally use as a guide and 3D print them so that they could actually come out and practice their surgery on an actual model before they perform the surgery. And so we take those CT scans and we print out these models, and surgeons can actually insert their tools and do whatever they need to do to the model before ever putting a patient at risk. And we hope for complex surgeries, this increases patient care and the success rate of complex surgeries. So I'm really passionate about 3D printing. I think it's going to change the world, and I think this is just one pretty cool application that we were able to develop to help bring that about. And so I have a few people I'd like to thank for the support of this project. I have to thank Dr. Matthew Levy for his endless support on this. It was kind of a leap of faith taking this project on even in the first place. This has never been proven before, and so I'm really happy that he decided to support this project. And I'd also like to thank these organizations for their financial support. Without them, it wouldn't have been possible. And I'd also like to thank my colleagues and dear friends, Lauren Crumdick, Justin Diener, Connor Wathen, Sarah Chapman, and Tony Van Avermaet for helping us on this project. So I'm really excited about 3D printing and what it can do for every aspect of our lives, including the medical one. And I hope after this, you are that way too. So thank you.